All right, here is a hypothesis test for standard deviation. And they give us the null hypothesis. Null hypothesis is that sigma is 52. So the population standard deviation is 52. And for some reason, we are going to test, they think that the sigma, the population standard deviation, is less than 52. They tell us that it is a random sample. Our sample size is 25. And it is obtained from a population that is known to be normally distributed. Very nice of them to do that. And so the first thing they're going to do is they're going to ask us to compute the test statistic. They're going to tell us that the sample standard deviation is 45.1. So they took a sample. Here is the standard deviation for the sample. And we're going to find our test statistic. Okay, since this is standard deviation, it's going to be a chi-squared. So chi-squared naught, I guess we could say. And we have a formula for that. The formula is n minus 1 times the s squared over the sigma squared. Okay, and you probably recognize some of this stuff. This is your degrees of freedom. This is your sample. S is for sample standard deviation, and the Greek letter is for your population standard deviation. And I think they give us all these numbers, so let's just go ahead and put them in. N minus 1, n is 25. S squared. Now, we know that S is 45.1. So we have to take that 45.1 and we're actually going to square it. And then it's all over our sigma squared, which was also given to us as 52. All right, put this in your calculator. Let me make sure this is a minus right here. Put this in your calculator. You're actually going to have to square this. You're actually going to square this. And you will get 18.053343 and on and on. Okay, so this is our test statistic. And they're going to want to round to 2 decimal places, so 18.05. Part B, they're going to say that they want an alpha of 0.10 level of significance, and they want us to find the p-value. They want us to approximate the p-value. All right, well, we need to go look at the chi-squared table. Let me get that up. So here is the chi-squared table. Knowing that this is the area on the right-hand side, and that's not what we want because what this is, sigma is less than 52, was in our alternative hypothesis. So instead of looking at the right-hand side, at 0.10, we're going to look over here at 0.09. Okay, and then 0.95 would be the 0.05, 0.975, and so on. So we look at our degrees of freedom, which is 1 less than the sample size. So our degrees of freedom is 24. And when we look at 24 and we're looking at these values, we're looking for our 18.05, and we notice that it's bigger than this, it's bigger than this, it's bigger than this. So it is going to be bigger than 0.10. So our p-value is going to be approximated as being greater than 0.10. Okay, and that's going to be the answer here. So our p-value is greater than 0.10. Okay, it would be different if we saw it in between some of these values, then maybe you'd say it's in between 0.10 and 0.05 if it was in between here, but it's kind of off the chart, so it's greater than 0.10. Now, summarize, okay? Our p-value is greater than our alpha. P-value is greater than alpha. And if that's the case, we do not reject the null hypothesis. Okay, we keep the status quo. This thing has to be super small, really, really small, smaller than this, for us to reject the null hypothesis and look at the alternative hypothesis. Since the p-value is greater than alpha, we do not reject, and that is at a level of significance of alpha is 0.10. Do not reject the null hypothesis.